Hello everybody. Today I can find a missing side of similar triangles by creating a proportion and cross multiplying and solving. This lesson really lays down the foundation for the entire similar triangles unit. And let's get to it. In the diagram, triangle Jack is similar to triangle Sun. Find the measure of SN. Well, I know that the corresponding sides of similar triangles are in proportion. So I want to put the corresponding sides on top of each other. So 8 and 12 correspond, so I put those on top of each other. And 9 and 9 and X correspond, so I put those on top of each other. I put an equals in between them. That's how I set up my proportion. Now make sure if this is the left triangle and this is the right triangle, if you go left over right for this side of the proportion, you must also go left over right for this side of the proportion. You could go right over left, but you have to be consistent. So I always just go left over right equals left over right. That way I don't have to worry about it. Once I create my proportion, to solve it, I cross multiply and solve. 8 times x is 8x equals 12 times 9 is 72, is 108. From here, I divide by 8, divide by 8, x equals 108 divided by 8. I can use the calculator. I think it's going to be a decimal. 108 divided by 8 is 13.5. So we put our corresponding sides on top of each other. 8 and 12 correspond, so they're on top of each other. 9 and x correspond, so they're on top of each other. From there, I cross multiply and solve. A common question that you see on the regions is something like this. Let's actually do this one. CD is 6.6, DE is 3.4, CE is 4.2, BC is 5.25, and it's asking for AC. Always put an X on what you're trying to find. So the tricky part here is what corresponds to what. This is a very common picture you'll see for number 5 and 6 and 7 and 8. It's all the same picture. The corresponding side is diagonal from it. So it says that these lines are parallel, which means that B and E are alternate interior angles, which means that B and E correspond. So what corresponds? BC and CE. The sides that correspond are the sides that are diagonal from each other. So when I put my corresponding sides on top of each other, 5.25 is going to go over 4.2. And then my other pair of corresponding sides, X, is going to go over 6.6. In this case, I don't have the side that corresponds with DE, so I'm not going to use that piece of information. I put an equals between them. That's how I create my proportion. Again, the corresponding sides are diagonal from each other when you have these twisted, rotated triangles. So the 5.25 corresponds to the 4.2, and the X corresponds to the 6.6. From here, I cross multiply and solve. 4.2 times X is 4.2X. 5.25 times 6.6 is, I don't know, 5.25 times 6.6 is 34.65. Divide by 4.2, divide by 4.2, X equals 34.65 divided by 4.2. To the nearest hundredth, whatever, 8.25. So again, when you have these twisted, rotated triangles, the corresponding sides are diagonal from each other. 5.25 and 4.2. Let's just set one more up. We're not going to do it. It wants CB. So I know that 7.2 is going to correspond to X. And I know that 9.6 is going to correspond to 21.6. And you have these twisted, overlapping triangles. The corresponding sides, again, are diagonal from each other. And that's it for negative cross multiply and solve. So, to find missing sides, we create a proportion. We put our corresponding sides on top of each other. And if we have this twisted, rotated picture, the corresponding sides are diagonal from each other. Practice it. See ya.